Hey guys, thanks for sticking it out until this time. And we know, TechFest is coming up, but a couple more sessions to go. But this one, hopefully, we'll have a bit of fun. Looking at data and fun in the same sentence, but we'll try. We're all a bunch of geeks, so hopefully, data is fun. So, in this session, we're going to take a look at some topics around, we're going to have a quick introduction of StreamInsight. Okay, we're going to talk about Windows Azure and StreamInsight. And we're going to have a look at some scenarios around about, when you would want to use it and why you'd want to use it and what it can kind of give you. And hopefully we'll show you how to, using the preview of Windows Azure StreamInsight services, which is Project Austin. We'll actually show you how to configure it, deploy an app to it, and take you on a quick walkthrough. So as a show of hands, I know we've asked just before the session started, but who's used SQL Server StreamInsight before as a product? Okay, not many? Cool. Who's used some form of complex event processing engine before? Okay, cool. So a few people. Good. Well, let's kick into it. So as a way to understand streaming data, I want to kind of paint a picture for you, right? So if you have a look at that, that's a kind of cool car park. Sometimes that's what the motorway looks like at 8 o'clock in the morning. But if you wanted to know how many red cars were in that parking lot, okay, how would you go about doing it if you were in a relational database world? Okay? Well, if you were in a relational database world, it would be pretty easy. Okay? You would go to the car park and you would count where type equals auto and color equals red. Okay? And that would answer my business question of how many red cars are currently parked in the parking lot. Okay? Simple. And we do this all day, every day, in various kinds of forms. Okay? Some a lot more complex than that, some simpler than that, but that's kind of the idea. All right, but in the world that we live in today, where we've got mobile devices and devices out there in vehicles and air conditioners and who knows what, that's bombarding us with data all of the time, the kinds of questions that business is starting to ask about data is very different to how many red cars are parked in the parking lot. Okay? The kinds of questions that people are starting to answer ask is how many red cars have driven past a particular off-ramp within the last hour? Okay? Now, if you were still in a relational database world, how would you go about answering this question? Okay? One approach would be you'd probably pull all the red cars over, put them in a parking lot, and at the end of the hour, you'd go and count the red cars that you have in a parking lot. Okay? It's not necessarily the ideal solution. Okay? It is an approach, and it would work in a relational database world, but you can see that it's not going to be the most optimum solution. You've got to pull a car over and hold it there for a while, okay? Or you've got to put a copy of the car into the parking lot for every car that drove past. You can't give an answer real time. You have to kind of wait until the end of the period and then count them and then give the answer. So there must be better ways to do this kind of thing, okay? So to understand streaming data, we want to look at the fact that different kinds of questions require different ways to answer them. Okay. So we're not here to say that all your kind of data queries are now going to be done like this. Okay. It's a certain type of query is now going to be done using this kind of approach. Okay. So I can't walk too far away from the machine. All right. So what you would want to be able to do here is this kind of question that I showed you about the red cars past the parking or past an off-ramp. You'd want to be able to answer that with a stream processing engine. Okay. And literally what you do with a stream processing engine is you stand there and you would say, count the cars as they drive past and then deliver the answer. All right? So ask the questions about data in flight, okay, whilst it's still in flight without impacting the data in flight. Okay? Whereas with a relational database, you would kind of impact the data that's in flight and put it in rest first, then count the question. So we're about answering questions about your data whilst it's still in flight and moving. Okay, and that's introducing the concept of event processing. Okay, so you have all these events that are causing data to stream into a system, and you want to be able to kick off events that are happening as this data kind of comes in. So that's a definition from Wikipedia. I'm not really going to read the whole thing, but basically it's about processing data that's coming from events. Okay? And there's a concept, if that's event processing, there's a concept called simple event processing, and there's also a concept called complex event processing. Okay? And to describe and illustrate what complex event processing means is take the following scenario. Okay? A couple of men in black tuxedos appear. Okay? Then a lady in a white fancy white dress appears. Okay? And then my clicker stops working, so I'll stand close to the machine. And bells start ringing, okay, doves fly, all of these kinds of things. Now, any one of these on their own could mean any number of things. Okay? The fact that all of these are happening from different places, in different kind of times, all within, a proximity of each other, generally means something has happened. Okay? And in this case, the action of men appearing, a woman in a white dress appearing, bells ringing, doves flying, all within a period of 2 hours, probably means that there's a wedding somewhere. Okay? And that's the concept of a complex event processing. You've got all these events that are happening, okay? But looking at them as a whole, okay, you can deduce certain things that are happening because of all these different individual events. Okay? And that's called complex event processing. And complex event processing is what StreamInsight is kind of built for. All right. So some of the scenarios that we want to take a look at is, where would this be useful? So you've got infrastructure monitoring. Okay? You've got a whole bunch of infrastructure that's out there, and they're all raising these kind of data or telemetry events. And you want to be able to kind of look at this infrastructure and actually understand what this infrastructure is busy doing at real time. Okay? You've got some kind of real-time visibility into what your users are actually busy experiencing. So you've got some kind of a web resource, okay? And in real time, you want to get some feedback in real time about your user's experience based on what's actually happening. Okay? You want to be able to do some kind of web analytics. So you've got a web app that's out there, real time, not a week later or a month later. Real time, you want to see how many users are clicking on your site, how many page requests you're getting, how many times people are refreshing a page, how many times they're getting timeout errors, and that kind of stuff. You want to see that real time. Okay? And in the world that we live in today with devices and telemetry, you've got a mobile phone in your hand. You want to see real time what your users are doing, where they are, okay? The kinds of actions they're performing on their phone in real time. And you want to be able to see that as their environment's changing, their actions are changing. And we generally see those scenarios being applied across these kind of verticals. Okay? And there are a lot of examples in those verticals over there, from manufacturing to utilities, where you've got smart meters. Okay? Who's got smart meters installed at their homes that are doing electricity monitoring? Okay, so you've got all these meters that are out there, and they're busy raising events back the whole time. Okay? And it's lots and lots and lots and lots of data at frequent intervals. And you want to be able to, at real time, get some kind of insight into that data. Okay? You've got other things into risk and finance management and web and telemetry and GPS and vehicle diagnostics, and the lists kind of go on and on and on. Okay.
Yeah, so couple of key points that Ryan hit, and I just want to once again come back to those and re-emphasize in terms of scenarios. Any time where you have very, very large volume of events or data coming into your infrastructure that you are interested in, this is a potential candidate for StreamInsight, right? In terms of identifying the scenarios. And when I say very large number of events, we could be talking from a few thousand events per second up to the 400, 500, 600,000 of events per second hitting your endpoint infrastructure effectively, right? So the second characteristic is, am I interested in that data? Do I really care about it in terms of putting it at rest and keeping it over an extended period of time and then looking into it? Or do I want to look for certain patterns within that data, and only if certain conditions are met, or that combination of men dressed in black and the bride and the doves flying, only give me information about those events and those conditions? Right? So you're really interested only in data on the fly and immediate feedback about certain conditions. So what is StreamInsight? We were talking about data and events, and I already referred to endpoints and that sort of thing. So in our world around us, we have sources of events. They could be anything. They could be web properties. They could be smart devices. From manufacturing has a bunch of scenarios that, there are sources that emit large volumes of data again and generate events. But ultimately, there is something that produces a piece of data, and you want to run some sort of BI and analysis on top of that data. This is where StreamInsight comes into the picture. It accepts the data. It receives the events, in other words. And the way that we do that is within StreamInsight, we have the concept of a logical source that represents the actual physical source, whether it is a set of devices, web servers, whatever that is, right? What the source is completely under your control. So that's something that you implement according to some API that StreamInsight gives you. Then that source becomes the generator of streamed data that flows into what we call a standing query within StreamInsight. And standing query, Ryan had one of those in his sample again with the picture, right? He had a query such that when men appear and a bride appears and doves flying, then action or fact is that there is a wedding, right? We reached a conclusion. So this is what we call a standing query. And that query keeps on executing over the incoming stream from the source all the time, right? You might have heard of a pattern called observer and iObserver and iObservable interfaces. The reactive extensions library within the .NET framework took that pattern to a whole new level, and then StreamInsight puts the sugar on top of that. And you end up basically with those standing queries that work on streaming data as it comes into StreamInsight from the source, whatever that source is. What is interesting is that what the standing query produces as output, which is the entries that match that standing query, is another stream. So with that in mind, you can basically chain queries on top of each other. So to put that into a slightly simpler version of the standing queries, you can say, first query is, give me the number of event log entries from a Windows server, for example, that have been generated over 10-minute periods. So every 10 minutes, at the end of a 10-minute window, you would end up with a count in real time of the events that sit within that 10-minute window, right? Next window, next window, next window. So that will be your first query. So the output from the standing query that gives you the counts over 10 minutes will be a stream on itself. Very slow-moving stream, because you're only going to get one event every 10 minutes, right? But it is still a stream. The second query on top of that can go, OK, from my input stream, which is the result of the first stream, only give me where the count is greater than 10,000 events over those 10 minutes, because then I have some sort of a problem, right? And I took that to the extreme over a 10-minute window. You would normally do that over a second window or over 5 seconds or 10 seconds window, right? So that's your real-time monitoring in a way. OK, and then the output of the standing queries goes into something that we refer to as a sink or an event sink in StreamInsight. And this is obviously representing the destination of where those events you want to land up. And that could be a bunch of places. It could be in a database. It could be on some sort of real-time dashboard that is notification-based. So you push the data to the dashboard, and it immediately presents it. We have a demo on exactly that thing. But this is basically what we are looking at right now, is the end-to-end architecture of StreamInsight, a technology that has been into SQL Server since SQL Server 2008, or at least it was shipping together with the SQL Server 2008 media on the CD. The technology is implemented as 2 libraries. One of them is the server library that you can host, or we also have a Windows service out of the box that can host that library for you. And you also have a client library that you develop against in your development environment. So Visual Studio, .NET, you work with .NET classes to represent your events and so on and so forth. And then you have LinkPad as well. I don't know whether you've used LinkPad, but it's basically a notepad for link, which is where the name was, surprisingly. Right, so here we have an example of a query. So what that says is that slice the time, or the timeline, the real-time timeline, into windows of 10 seconds. And for each window of 10 seconds, give me an average of the water pressure value of all the events that fit within that time window. Make sense? Simple enough. This is just one query. You can chain, as we explained before, the output of that query into the next query that does something else.
So while we're looking at this query, one of the important differentiators here is that this is counting the data as it's flowing through the system without necessarily impeding the data. Okay, it's not going to a database and trawling through 1 million records every 10 seconds to work out what the average is. It's an in-memory sliding kind of query that just kind of keeps calculating as the data flows through it. So it's really, really, really blisteringly fast.
Yeah. In terms of scale, I already mentioned 400, 500,000 events per second. This is the kind of scale of input that we are talking about into the technology. Let that not mislead you and say, oh, OK, this is not for my scenario in New Zealand. I only get up to 10,000 events per second. That's fine. You are going to see a scenario during our demo that we are going to have about 30 events generated. And StreamInsight is going to do the real-time aggregation as well. So we decided that moving that technology into the cloud as part of the Windows Azure platform is a very sensible thing to do for a number of reasons. The first one is that in many cases, especially when you start looking at web apps and social applications where real-time BI really makes sense, is a common requirement as well, is because the data is already on the cloud. We have so many ISVs, you guys, or some of you, that are implementing cloud solutions on the Azure platform, and all your events are happening in the cloud. So why not have this engine running in the cloud as well, instead of bringing the data back to New Zealand on premises, doing some analysis here, and then shipping the result back to the cloud? Doesn't make sense, right? Another one is that such applications are globally distributed. You have a customer base in Europe, customer base in America, and in APAC. So the Azure platform, which is globally available, should be able to basically assure proximity of your event processing to wherever the client base is. In many cases, it's completely global. So a bunch of reasons why you would deploy a technology like this to the cloud. Again, reduced TCO, elastic scale out, service node infrastructure, the common suspects or the usual suspects for cloud deployment, so nothing new there. So what is Windows Azure StreamInsight? How is it different from StreamInsight on premises, which is what we looked at already? And the answer is that, in fact, it's not. We have a bunch of infrastructure around StreamInsight to make it hostable and running in the cloud and accepting events and producing events out of StreamInsight in the cloud. But at the core, the engine itself, it is still the same engine as StreamInsight that is included with SQL Server. So, Ryan, do you want to walk these guys through the parties involved?
So yeah, you got an IT pro who kind of says, well, I've realized that for this particular application and the kinds of questions my business is asking me, StreamInsight is the right technology for me. So I go to Windows Azure, and I go to the admin portal. And inside the admin portal, I configure an instance of Azure StreamInsight. Okay? And that then has a management kind of API that then talks to the StreamInsight server, and that provisions up a bunch of stuff. Now, that's also available through REST. So like all of our management stuff in Windows Azure, if you can do it in the portal, you can do it through a REST API. What does that mean? It means that you don't have to kind of go to a portal and click, 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 click. You can actually write some code to automate this kind of stuff, right? So what ends up happening now, those event sources that Neil was talking about, wherever they are around the world, globally distributed, okay? They're feeding things into the StreamInsight engine, and the StreamInsight engine runs the analytics and the standing queries on your sliding windows, and it outputs it to a bunch of destinations, okay? And we've got things like Azure storage, SQL storage, that kind of stuff built in. We've got service bus capabilities. Plus, we've also got the ability for you to write your own custom event sync if you want to store it somewhere other than what we ship out of the box. We've also got the ability to kind of take that information and ship it into something like Hadoop, okay? And we've got Hadoop on Windows Azure, so now you can actually take real-time information, feed it into a massive big data processing engine, and do big data processing on the events that StreamInsight has spat out, if you wanted to.
So can I interject just for a moment? The interesting thing with this infrastructure is that you now have real-time BI capabilities and notifications and alerting for certain conditions, right? And that's delivered through the actual StreamInsight processing and the standing real-time queries that we were discussing before. But at the same time, as a parallel stream, you have output of the raw data that hits StreamInsight, right? Into persistent storage. It could be a database. It could be Azure Blob Storage. And then you build Hadoop on top of that, which does your quarterly, yearly processing and numbers at the end of the year.
And when we get to one
for your heavy-duty reporting.
Yeah, and when we get to one of the scenarios at the end, we actually have a scenario where we're working with a customer here in New Zealand, and we'll show you exactly in their architecture how we're doing exactly that.
Very similar to this, yeah.
Yep. Cool. So the parties involved are generally, the IT pro who goes into the portal and configures it. Okay. You've got the data architect who says, hey, what kinds of event sources is my company or my application? What kind of event sources am I generating? Okay, and they define those for you. Okay. Then you have the data scientist who kind of sits there and goes, well, cool, data architect has said I've got this kind of data, that kind of data, this kind of event source, that kind of thing. What meaningful information can I get from it? And these are the guys that draw the cool, pretty pictures, and maybe they could be like Jer, and they create funky graphs and all sorts of data art. But basically, using the data that this application or my business is collecting, what can I do with this? Okay? And those people together usually hand it over to a solutions architect or a developer who then uses Visual Studio or LinkPad or whatever, builds the queries, defines the outputs, and then deploys them into StreamInsight. Okay. So, cool.
Cool, all right.
Into the first demo.
Fingers crossed. Okay, so on one of the slides, we had actually just the previous slide. We had a picture of how the IT pro interacts with some provisioning API. And the result of that provisioning API was an instance of StreamInsight running on the Windows Azure platform. Just for your reference, that whole technology, StreamInsight in the cloud, is codenamed within Microsoft Project Austin. So if I start referring to that as Project Austin from now on, don't be surprised of what I'm talking about. That's StreamInsight on the cloud. So the technology at the moment is in preview mode. It's not available for production deployments. And the portal itself, the portal experience, is not available either. So you only have the management service, which is a REST-based service. So whatever you want to do with Project Austin, you do it through that management service. And this is what we are seeing as part of that demo. I split the code into a bunch of regions so that it is easy to read. The first one is connecting to the Austin management portal effectively, deploying a bunch of custom assemblies, and those are required for our own .NET data types. That's the type of events that we are expecting StreamInsight or Project Austin to receive. Then we define the sources. What are the endpoints where we want devices to stream data into or events into. Then we are going to define the consumers, and those are the guys that output the result from the standing queries from the StreamInsight processing. And then we are going to define the actual analytics, which is the standing query. And finally, the last piece in the code is going to start this whole pipeline: source or endpoint, standing queries, consumers or sinks that write to the destination. OK, so enough talking. Let's start expanding the code sections. Connecting to an Austin instance is pretty easy. So
can everyone see the code sample? Big enough? Go.
Yeah. So that line here that I have highlighted at the moment, this is connecting us to StreamInsight management at a particular endpoint address, which is defined in the application config file. And that's right here. Actually, no, hold on. It's not this one. Yeah. So the StreamInsight management endpoint is defined right here. So Austin management URL. In fact, you will see that some of the settings still make references to Austin. So this is the provisioning interface. And then as part of this, actually, the first demo is not defining the sources and the queries and the destinations. The first demo is purely provisioning the Austin instance. And the app config file that we were looking at is sufficient to do that. So it is prompting us for our Azure subscription, where Austin will effectively be instantiated. The hosted service name that I want to deploy the Austin instances into, a storage account that the Austin instance needs to use, and a bunch of other details. So if we run this sample now, that's the service provisioning project, it will use these settings here to go to the management REST service. And in a few moments, well, may not be a few moments, it may be a minute or two, what we are going to see is that under the TechEd Live service, we'll start getting some activity. And this is where the Austin Management API will be creating the Austin processing instances effectively. And we have two instance types, or two roles. The first one is the receiving endpoints, so instances that are running the receiving service, and then an instance that runs the actual StreamInsight engine, or the brain of Project Austin. It's finished. Hold on.
Just retry that, or refresh that. Yeah.
Oh, that good here.
Oh, there you go. Well spotted.
Yeah. OK, so I'm actually not going to wait until the result. We'll come back to that to make sure that it's working correctly. But there is no point waiting for this result, since we already have a Project Austin instance pre-created. And I just selected it. It's called TechEd NZ StreamInsight. And we can see that we have 3 instances in total inside that cloud service. 2 of them are the ingress node, or this is the receiving role within StreamInsight. And we have the 1 instance that runs the StreamInsight engine. So that will be the provisioning. Yep. It will be going for about between 12 to 14 minutes. And this is what's happening. Yeah, that's running now. So we'll continue with the slides.
Cool.
And then when we get back, this service will be provisioned.
Awesome. Cool. So as you see there, it was kind of creating the ingress nodes and the analytics nodes. And those ingress nodes, obviously, you can scale those out. So that's how you get massive amounts of throughput and get your service to accept massive amounts of data. And you have your analytics node, which, if you're doing really heavy queries, you can make, have a small machine or a big machine or an extra large machine. OK, so let's kind of take a look at a high-level architecture of what we kind of end up building. So you've got these events. OK, you're collecting them. Okay? Currently, out of the box, we ship HTTP sources. Okay, so I can accept any HTTP traffic. I then feed that into 1 or more ingress nodes. Okay, and in the ingress node, I can do things like decode. I can debatch. I can transform. Okay, so I can take it from one format to another format. I can enrich the data. I can get the data coming in. I can actually call out to a web service or look up some values in a database or do some things, okay, to enrich the data. Okay? Once the data comes in, I can do other things on it. I can authenticate the caller, so I can make sure that it's only authenticated devices or infrastructure that can actually hit my ingress node. So I can do a bunch of stuff while the data is coming in to my service. One of the things that I can do, and that's what Emil was alluding to earlier with the Hadoop on top of StreamInsight, is one of the things I can do is I don't have to do any of those steps. I can just have a kind of throughput pipeline. Okay, so I can just receive in data and then batch bulk dump it into blob storage. Okay, so I can just receive in massive amounts of data through these scaled out ingress nodes and just pump them into blob storage. Because the StreamInsight blob storage sync is kind of optimized for really high throughput performance into blob storage. Or I can run a bunch of decode and debatch and transform and then dump it into blob storage. Okay? And at this point, we haven't even involved the analytics engine yet. It's just received data and it's dumping the raw data. So I'm not running any BI on it at the moment. Okay? Then what I can do is I can take those streams and I can feed that into the analytics part of StreamInsight. Okay? So up until there, it hasn't been StreamInsight. Up and now, we can actually feed that into StreamInsight. And that's the part that's actually now, we can run those analytics, you know, and the standing queries and the time spans and the rolling windows and all that kind of cool stuff. So I can then do filter and analyze and aggregate and correlate and detect patterns and do all that kind of cool stuff, right? And the output of that, I can then dump into SQL database or into Azure storage, okay? I can also, if HTTP is not enough, okay, I can actually define my own custom ones. So if I had devices out there that were, you know, broadcasting UDP traffic, okay, I can build a UDP custom source if I wanted to, okay? And I can also build custom event syncs. So if I didn't want to write to SQL Azure or Azure Storage, I wanted to write to something else, I can actually build my own custom adapter. And that stuff that sits over there, we then add on top of it. So part of the Project Austin capabilities is management and service monitoring and that kind of stuff. So that at a high level is what we're talking about when we talk about Project Austin or Windows Azure StreamInsight services. Okay, so the capabilities that we've given you is around connectivity. Okay, so we've got a way to connect to a whole bunch of different devices. There's different kinds of standards that you can use. Okay, so REST, XML, JSON. And if you're doing like really high volume kind of things, you want to go as lighter weight payload as possible. So, you know, try use JSON, much lighter weight than XML, for instance. Okay, you can do data enrichment, and in the sample that we'll show you just now, we actually reach out and do data enrichment based on the location of the device. So we actually call out to a service, find out some information based on your latitude and longitude, and then use that info as part of the query. Okay, we can do rich temporal kind of analytics. We can do sequential or that reactive analytics. Okay, we can do dynamic stuff at real time. Oops, what did I just do? I think I just hit a blank screen. Hold on. Thank you. Whew. Whew. And we can do this at a multi-tenanted kind of layout at massive scale because we can just scale it out. Okay. We've also got the ability to do security. So at that ingress node, I can have authentication done through something like Access Control Service. So I can say, before you send me data, actually go and authenticate yourself. Okay. We can have some monitoring. So as StreamInsight has got the monitoring abilities to query what's happening as this data is flowing through the system, that's available in the Azure version as well. And then there's a bunch of tooling that you'll be familiar with around diagnostics and development and tracing and all those kind of capabilities. So because of the fact that it's built on top of and leveraging the Windows Azure infrastructure, it gains and benefits from many of the Windows Azure capabilities, like uptime because of the redundant instances and that kind of stuff. Okay. This is what Emil was talking about just now, where you can take the actual historical data and you can spool it into something that you can actually then do historical analysis on top of. Okay. So you get the real-time capabilities, plus you can spool it to a persistent store and then be able to run actual, you know, BI or historical kind of analysis. And it integrates into Windows Azure integration through SQL Server database, Windows Azure storage, that kind of stuff. Right, so back to Emil for a demo. And now you're actually going to demo the...
Now we are deploying the application that I was
deploying the application.
Showing before. So, okay, from the previous demo, the console application provisioning the Austin instance itself is still running. And as we said, eventually it is going to come back 14 odd minutes later. But if we look at the service where we are provisioning this, we should see the instances.
Yeah. So it's created.
Yeah. So they are being created as we speak, right? We have one ingress node instance and one processing nodes instance. This is from the demo that we just ran 5 minutes ago. We are not going to use this infrastructure. We are going to use the one that we pre-created just for speed. Okay, so now we are going to deploy an actual Project Austin application, something that does something, a real analytics, real BI, real-time BI solution. And again, I'll go over the piece of code that we had before, or the comments. deploying such an application involves the steps that we looked at previously. Let me just minimize that again. So connect to the running Austin instance, in this case, the one that we already have provisioned, push in custom assemblies, define source mappings and transformations, create the consumers, define the analytics, which are the standing queries, the brain of StreamInsight, and finally start the whole end-to-end pipeline processing. So connecting to the Project Austin instance, as I said before, is pretty much this single line right on top. There is a config entry in the file that tells it where exactly to run, and it is basically this thing here. TechEd, NZ, StreamInsight, Cloud App Net, and that's the StreamInsight management port, and then some suffix for the path. So this is how you manage your StreamInsight instance.
And that URL you would have got from the Azure management portal in the cloud service that is busy getting created in the background by that provisioning exercise.
Correct.
You would go in there, you would copy that URL, and then you would say, all right, now this is the StreamInsight instance that I want you to connect to.
So the next thing that we are going to do is push in the custom assemblies that we would like our solution to rely on. And there is a bunch of those, as you can see, 5 assemblies. And then we have a helper function that basically deploys them to Project Austin. I'm not going to dig into the details. The next line, or the next section, defines the sources. And this is where the real Project Austin code starts. The Project Austin client library that we mentioned earlier in the presentation has a class called HTTP source. And this class is a generic class, which you can type with your own type that represents the event that you are going to be pushing in. And in our case, the event is called tag event. If I jump to look at that event, here is the tag event public constructor or constructor. It takes 4 parameters: latitude, longitude, address, and user agent. This is basically the type of browser. It has public properties. The event has public properties for these things. But it also has, what does it have? So it has a bunch of additional properties called user agent name, user agent version, OS name. We didn't have that piece of data in our incoming data stream, in the incoming events. This is the enrichment and transformation functionality right here, where as part of this parsing effectively of the incoming event, we call to additional enrichment logic. In our case, it is to decode the user agent string. And that function populates what is the OS, what is the version of the browser, and the actual meaningful name of the browser instead of some coded string that we receive.
And like you can see, I mean, this is just custom code that we write. I mean, in our case, it's a really simple example, but you can do whatever you want here. Okay, if you can write it in code, you can do it here.
Look up against the database, get
call out to a web service to go and look up a postal code, or you can do whatever you want really. If you've got like a street address and you want to look up a zip code, you can actually call out to a web service, look up the zip code based on some property, and put it into the data stream.
Yeah. So in the code from the StreamInsight API, we are asking it to create an observable data stream, right, based on the incoming requests, where the tag events are populated from the query string lat, long, user host address, and user agent, right? So that's the place where we instantiate each individual tag event, and we create the stream from that event. We register that source at a particular URI, and this is the input HTTP address that your application needs to feed its events into. The consumers, we have pretty much similar logic. We basically say that we have a consumer that receives the count of events, right? And the type of consumer is Azure Table Sync. This is built-in functionality into StreamInsight. We register another sync called Census Table Sync. And again, that's of the same type. And then we have a custom sync called SB Observer. Okay? SB in this case stands for Service Bus. That's the Windows Azure messaging bus that you can feed messages into, and that will deliver the messages to whoever the consumer of those messages is. So in this case, StreamInsight will be producing 3 different output streams, 2 to Azure Table Storage, and 1 to a messaging bus that someone will need to consume events from.
So 1 stream of data in, 3 streams of data out is effectively what's happening here.
Yeah. And then the analytics. So this is the actual query or queries that we'll be running. I'm not going to fool anyone. The syntax of standing queries in StreamInsight is not straightforward. I mean, to start with, it's link, and there is lambda expressions, and then there is StreamInsightness into that. So additional complexity that comes from StreamInsight.
Which is one of the reasons. Which is one of the reasons, sorry, that we actually said LinkPad is a great tool for developers when they're building StreamInsight. Because if anyone's built complex link queries, you know that LinkPad is your favorite friend in the world, because you can actually build the query, and while you're still busy building it, you can actually check and test it quickly without, you know, having to compile and deploy a bunch of stuff.
But it is actually at the same time, it's not that bad. So let's follow that a little bit. From the incoming stream, which in this case is called tag subject, we want to select events of a new type that we create on the fly. That's an anonymous type that we are standing up. And that type has some properties of the original events. So census block latitude, census block, you know.
Language.
Yeah. So those are groups that we create based on the properties of the incoming events. And then from those groups, we split the real time, the real timeline, into 10-minute windows, right? And we produce output, which is census ID, latitude, so the coordinates basically, and the number of events that came from that block of coordinates effectively, right? So this is the event that the consumer, or at least the census consumer, is going to receive every 10 minutes. Well, in real time, but grouped by every 10 minutes.
And in our case, that census consumer was the service bus sync. So every 10 minutes, StreamInsight's going to publish one of those custom objects into the service bus queue every 10 seconds, I think it is.
The other 10 minutes, yeah. The other query that will be running against the source is slightly simpler. And it is saying, from the incoming requests, the tag request looks like this, right? And this is pretty much all we get. So, yeah. So from the tag subject, or from the source, group by user agent, and that's the type of browser. And then again, split the timeline into an interval. And the output that we will producing is of type agent count results, which has the agent name and the count. So as we push events in, we are expecting, let's say that we produced 2 events from Internet Explorer and 1 event from Opera, just random events, right? What we are expecting as output from StreamInsight is 2 events. One of them is going to have Internet Explorer count 2. The second one is going to have Opera count 1.
Okay.
Right?
I think the best way to show it is to actually
run the demo.
Run the demo and show it working. So while Emil kind of does that.
Well, let me just show where we start the process.
Okay, cool.
This is the chaining of the process. So we are saying from the tag stream, bind on top of that the census query, the one that groups by coordinates and that sort of stuff. On top of that, run the agent count. And that defines our process. And then the next line here basically says, start this whole pipeline from the stream to the census query, to the agent count query, to the output. Yeah, that's about it.
So while I hand these out, if you want to walk through, there's a couple of slides that show in nice, pretty pictures what we're about to do. And while I hand these out,
so
grab one of those and read the instructions on it. So this is called interactive demo.
So the first one was the demo of actually deploying your custom solution. We are continuing with another demo that will be actually showing what we are running as part of that solution. And what we see on the screen now and over the next few slides is a description of what we are doing. You have the sheet that has the e-tags. And eventually, we will ask you to scan those tags and action them, but don't yet, right? So ultimately, your mobile phone will be scanning the tag. It will be directed to a URL. And that URL is the endpoint of StreamInsight, the ingress endpoint, the place that accepts events, right? StreamInsight is going to get the event, OK? And it will run it through the processing engine. So there are two queries, as we've seen during the provisioning process. One of them is the one that counts the user agents and runs the group by user agent. The second one is the one that runs the census grouping, okay? And that's enriching the data from a SQL Azure database. So those are the two queries. And then the first query with the user agent count will be going into table storage. The second query with the census information will be going to the service bus, putting a message in the service bus, which is kind of a notification message. And then the consumers, we have two of them. On top is our web portal, the real-time BI analytics, which shows us the counts per user agent. And the second one is effectively a real-time consumer of messages that come from the Azure Service Bus, right, with the information of users geographically placed on the map based on their coordinates. Obviously, we have all the event producers in a single room, roughly at the same GPS coordinates. So the first thing that we are going to do as demoing this is ask you to scan those tags. Don't do that yet, so that we can see the information flowing real time. But we'll ask you to scan those tags and follow up on them, which will take you to the receiving endpoint for StreamInsight. And then we'll be showing the portal how the numbers are going to change as you navigate to this address. Then Ryan is going to start the map dashboard, effectively. And then we are going to run a random generator that is going to place events into StreamInsight at different coordinates from New Zealand. And we picked 3 locations. We have randomly generated Auckland, Wellington, and Christchurch values. So we'll see basically those 3 cities showing some activity on the map dashboard.
Cool. So if we jump then into the demo.
Switch machines.
Well, no, don't switch machines because the dashboard's on my machine.
So which one are we showing first? We're showing the browser.
So we're going to show the browser first.
Let me do that.
Are you going to bring up the browser?
I'll bring the browser up, yeah. So the browser is running as a cloud app again.
It's running at TechEd.nz.cloudapp.net. You got it?
Yeah. TechEd NZ, there we go.
Got it?
Yeah.
Sweet.
OK, so this is the agent count dashboard, which hopefully, if no one's
OK, so
Safari.
if you want to
We've
grab
got
your
Safari
phones,
users?
we've got Safari users. So
who are the Safari users?
Who are the people
Identify
in the phone
yourselves.
that have iPhones? Come on, be brave.
Safari.
There's an iPhone. So
there we go.
iPhone, anyone who's got you're effectively a black sheep. You can wear that proudly. Who else is an iPhone user? Come on, own up.
Time to probably start scanning, by the way.
What size shirt would you like? You can have Extra large shirt. Wear your shirts with pride, if you wish. There you go. So you can start scanning if you wish, and that should hopefully change, and hopefully we'll get more IE than Safari. Let's hope. Depends on the crowd that we have, I guess. It should just refresh on its own, because that.
Yeah, I'm refreshing it just to speed it up a little bit.
Come scan over here, because it looks like we only have.
Oh, there we go.
There we got an IE mobile.
A lonely one.
We've got four iPhone. Oh, there we go. There we go. We're catching up. Come on. Oh, who's got an Android? Who's running Android? There you go. You can get a T-shirt too. Have a T-shirt.
So imagine this running at hundreds of thousands of events per second. Right? That's not something that you can do with a database or with a data warehouse or with analysis services or a technology alike, right? It is live information, hitting us, immediately, getting the BI. And some of these queries could be quite complex. When we were talking about the architecture, we were talking about standing query feeding into another standing query, because the output of the first query is a stream that goes into the second one. Well, guess what? You can do correlation between streams, meaning that you can run two queries straight from two different sources. So you get data from one source, one type of events, data from another source into a second query, and then you can marry the output of these two queries together into an aggregating query on top of that. So now we start getting into the real complex event processing once you start looking at multiple queries correlating with each other, and you can create that correlation based on timeness of the events as well as the actual business payload of the events. Extremely powerful technology.
Okay, so there we got 22 kind of events that you guys have scanned, and keep scanning if you want. Keep hitting refresh on your browser, and that number will go up. Okay?
So that's the number of people that we have in the room then?
No, that's the number of times they've hit the scan.
Well,
not necessarily a one-to-one
Fair
match,
enough.
Right? But anyway, you can kind of keep scanning, and that number should go up. But like Emil was saying, it's a little bit of a dud demo at the moment because everybody's in the same room, and therefore it's all showing everybody in Auckland. So if Emil starts up his Mayhem generator, which kind of just, adds some extra events, we should start seeing other tags appearing. And this is that kind of enrichment of the data. So everybody's sending through their raw latitude and longitude, but what we're actually doing is grouping them up into blocks, okay? So we're saying all of these events, even though your minutes and your seconds are slightly different, you're all within Wellington, you're all within Christchurch, you're all within Auckland.
Release the hounds.
So
that's coming.
So it's starting up, and we should start now. So there you go. So that's pretty much real time. So those events are coming from Emil's machine all the way to Singapore, and then they're coming all the way back down to my machine via the service bus. Because this is a client that's running on my machine, but it's wired up to the service bus. Okay? So you can actually see that even though this is going all the way over to Singapore, through the service bus and all the way back down, it's actually pretty responsive, and there's not much latency going on over there. Okay.
Well, I just spoke to one of the individuals in the room earlier on today, doing some perf testing via the service bus, and he just went up to 100 messages per second, not even trying, right? So throughput of the service bus and latency is not really a problem. Sorry? There we go.
Cool. So that's it. That was the demo. Thanks to all the black sheep in the room. Thanks to the actual IE people too. It was good to see.
Cool.
It's one of the first times that I must say that I've done this, that there have been more black sheep in the room than not. But that's okay. We love you too. It's fine. What slide are we on? Hold on a sec.
Not this one.
Not that one. We're down there, right? Cool. Where's the clicker? Okay, so that was kind of our tag event demo. Now let's take a look at some customer scenarios, because even though this is actually still in preview, we've got some real live customers running on this today. Because it was such a compelling story that they came to the engineering team and said, look guys, it's going to change the way we do our things, and we really do need it. What can we do? So we've got a TAP program, and some customers are actually running on it. Now, we've got some security software company. We can't tell you who it is, because they didn't want us to tell you the inner workings of how their software works. But basically what they've got is they've got today about 100 million clients around the world. Okay? Very shortly, that number's going to jump over 1 billion. Okay? So by 2015, they're going to have over 1 billion customers around the world that are sending them events every second. Okay?
Think of companies that have 1 billion customers.
Yes. So basically what's going to happen is there's a telemetry front end that's going to be receiving this information from 1 billion different devices around the world. Okay? And it's going to get fed into StreamInsight, and with StreamInsight, it's going to be persisting the raw data. Okay? And it's going to run some cool complex queries. It's going to dump the aggregated data into SQL. And from there, there's going to be a query that actually goes out to a WCF service to alert a team. This is about the fact that, you know, in a security software company, you might have false positives. Okay? You might get a virus definition or a virus alert, but it's actually not really a virus. Now, what you want to do is very, very quickly, in real time, shut that down and make an adjustment to your queries before you shut down or disable 1 billion machines around the world. Okay? You want a team to very quickly notice a bunch of complex events that may have happened and determine that this is actually a false positive, it's not actually a virus, and therefore please don't go shut down 1 billion machines around the world. Okay? They can then actually go and do some queries. They can then change some stuff, make some modifications to the notification engine, and, you know, we can then feed that back into the StreamInsight engine at real time to say, okay, we've changed the query, so don't actually look for this set of events, now look for something else, because the response team has actually had a look and gone, this is what we think is actually a real scenario. Okay? So this is a real customer scenario running today, live. We just can't tell you who. This is a customer that we can tell you about, and you may recognize some of those icons. Who recognizes at least one of those? Good. You all have to have watched Channel 9 at some point, right? Okay. So these are our audience kind of sites. So Build, Mix, all the events that we run, TechEds around the world, they all run on web stuff, and you can actually watch content from the site. And we want to get real-time analytics as to what's actually happening. What's the user experience like? Okay. So we've got internet out there. Okay. We've got our Silverlight player, and our Silverlight player is actually sending telemetry information into Project Austin ingress nodes. Okay. Those are being fed into, we're capturing the raw data again. We're doing some decompressing, debatching, and we persist it into Azure storage. We feed it into an analytics engine, and that then gets persisted to SQL. And we've got a dashboard that runs. Okay? So at an event like Build or Mix, and guys are watching these events real time, there's a Silverlight dashboard that's running, and we can see real time what's actually happening in terms of, you know, number of requests and how much we're streaming and the data that's going out and all that kind of stuff in real time as people are watching these videos around the world. Okay? The other one, this is a customer. Let me scan the room. No one from the customers here. So this is a customer that we're working with in New Zealand that is trying to deal with 60,000 transactions a second plus, okay? And they want to do analytics on this data. Now, even if that's a 1K kind of file that's come, or 1K message that's coming in, if you think there's 60,000 of those every second, okay, that's a lot of data. So what are we doing is we're taking those, we're feeding them into StreamInsight, okay, into the ingress nodes. We're persisting the raw data for historical reasons so they can actually see the raw events. We're then feeding that into an analytics node, and what we're doing is every 60 seconds we're doing an aggregation out of that, okay? That aggregation we're then kind of using Hadoop to look at the raw data, and we're then running reports on the aggregations of 60 seconds. So what we've done is we've taken 60,000 transactions every second, and we've produced one transaction every 60 seconds.
So it's a data reducer technology in real time in this specific context, right? Rather than necessarily real-time analytics.
Because even with something like Hadoop, if we didn't do a data reduce pattern, we'd be trawling through 5 terabytes of data a month. Okay, and that's just far too much data to actually trawl through.
2.5 terabytes a day, actually. Yeah, that's
Even
what
worse.
it accounts to.
All right. So we're almost out of time, but this is the roadmap. Okay, that's where we are now in the blue block. Okay, if you've got a strong business case for something like this, come speak to us. Okay, and we can see if we can get you into a TAP program. Okay, coming soon there will be a public preview release where you'll be able to sign up for it, like websites and media services and stuff like that. And there will be the portal integration, so you won't have to write code to do the management. You'll actually have a portal, all right? And then coming pretty shortly will be the general availability, and the actual pricing model will be finalized soon after the public release. Okay. So one last thing, and then we'll be done. The one that I want to talk about is this kind of up to one large extra instance of the analytics node, right? So the analytics engine that can run, you can scale up the ingress nodes to as many ingress nodes as you want, but there's only one analytics node. And people say, well, you know, that's a bit of an issue. What happens if I really want to process data? Okay. Well, that customer that's got 1 billion devices out there in the world, they're running on one large server. So they're not even running on the biggest server they can, and that thing sits at about 10, 20% CPU. Okay. So StreamInsight as a technology is optimized to do this kind of work, rather than you writing your own thing to kind of count them. It's optimized to do this kind of work, so let it do that kind of work. Right, so that's pretty much it. If you've got any questions, feel free to come around and ask afterwards. And
we are on time again.
We're on time again. Awesome. How about that? It's like we planned it. So thank you very much for coming around, and please remember to fill in your evals. Thank you.
Thank you.